Hello everyone, welcome to our webinar on metal forming simulation. My name is Corinne Bossy. I work in the marketing team at Altair in the UK, and I will be your host for today's webinar. And for this session, I'm very pleased to have online with me Rob Shropshire and Tim Dukes of Origin. Origin is a partner company of Altair, and they specialize in simulation for the manufacturing industry. And in today's webinar, they will provide an introduction to the Altair Inspire Form solution. So just before we start, a couple of housekeeping items very quickly. Your microphones are muted by default, but you can use the questions box in the GoToWebinar panel to ask questions at any time during the session. And we will have a few minutes at the end today to answer them. This session will be recorded, so in case you're not able to stay until the end, you will be able to get a link to the recording afterwards. Okay, so nothing else from me to add just now. I will just turn you over to Rob to get started.
Thanks very much, Corinne. Hopefully everyone can hear me okay and see my screen. Welcome to the webinar. Obviously today we'll be talking about forming simulation. Just by way of introduction, I'm Rob Shropshire and I lead the sales and marketing side of Origin. I won't be doing a lot of the talking today, but I will be your point of contact moving forward if you do want to chat with us further. I'm really pleased to be joined by Tim, who has been working in the manufacturing space for the last 10 years or so and leads things product related for Origin, as well as providing a lot of the training and support for our customers day to day. We'll also be hearing an interview I had very recently, a couple of days ago, with Jay Weiner, who is the owner of BiggerBoat Solutions and has been using Altair products for a number of years to provide forming simulation, die development and design services. He's got about 25 plus years in industry, previously working for one of Canada's premier tier 2 automotive suppliers before setting up his own business back in 2009. So introduction, very short, probably another sort of 7 minutes or so. I do think it's important just to, at a high level, explain what Inspire Form is and who Origin are. I'll then pass over to Tim, who is feeling brave and will be giving a live demonstration of the software to show you how we can set up some simulations and how we can get some results. We will be making a trial available for all attendees, should you wish to try it for yourself. We'll then finish off with the interview I had with Jay, where he'll discuss the challenges he faced before simulation, the importance of using simulation today, and why he felt Altair was the right partner for him. We'll then move into Q&A. So do ask your questions in the chat box. We have got a lot to get through, but we will be saving a couple of minutes towards the end for some questions. So Origin have around 200 customers. All of them are focused on manufacturing. We try and provide tools that are affordable and are easy to use. So all of the products that we provide take 1 day of training time to sort of get up to speed with. The end goal then is I guess providing an easy route for small and large businesses to either adopt simulation for the first time or to push simulation out to more people within a business by providing sort of easier to use tools. So in our experience, it's that pushing of simulation out to more users, and it's integrating simulation right from the start, right to the end of the manufacturing process, which will make the biggest difference. So we start with design engineers to help them inform part design, to conduct their feasibility, right through to the identification of defects, and then final validation before manufacture. We're really proud to be an Altair partner for obvious reasons, but we'll explain why we partnered with them as we move through. So we believe incorporating simulation from the start of the design workflow right through to manufacture, we can provide a safe space, I guess, to innovate and remove a lot of the costly trial and error exercises where we might invest a lot of design time and money on materials and tooling without necessarily having a clear idea as to whether that method's going to work or not. Naturally, by seeing defects early, we'll be able to increase quality, but we can also make sure our forming process is as efficient as possible, so we're making the best use of our materials. When we're quoting for a job, we can assess the part before we commit to the job. We can assess the formability. We can get an accurate picture of the complexity so that we can make sure that our quotes are as accurate as possible. Being able to solve complex problems for customers, and I guess prove that you're able to meet those requirements, we think will act as a point of difference. And we're seeing most OEMs, particularly in the automotive sector, already mandating simulation as part of that design process. So if you're not doing it already, if not for your own efficiency and your own profitability, there's a likelihood that most sectors are going to move that way anyway. So the earlier that you adopt simulation, we think the better. So I'm just going to provide a couple of minutes on what Altair Inspire Form is. Before I do that, we have got a quick poll just to understand whether you are using simulation currently. So I think Corinne's just going to pop that on your screen now, if you wouldn't mind answering it. So some opportunity for people to adopt it for the first time. And if you are already using it, is there the ability to expand usage? We see organizations with very advanced forming tools, but actually that means that other people in the business can't use it because it's too technical. So you be the judge when you see our software, in terms of how easy it is to use. So a couple of more minutes from me in terms of what Altair Inspire Form is. You're in safe hands to start with. So there are a number of organizations, both large OEMs and obviously smaller organizations that use the software. So it is trusted technology. One of the reasons we like working with Altair is a units-based approach to licensing. Now, what I mean by that is that Inspire Form, you can see it highlighted, forms part of a product suite. And with the same license, you're able to use any of those other bits of software at no additional cost. So you can spend your tokens on whatever product you want. When you finish using that product, the tokens basically go back into the pool for someone else to use. So it makes it really easy to use different pieces of technology. Perhaps you might get involved in some stress analysis as well. Maybe you're doing some 3D printing as well, so you want to look at the additive side. So quite a holistic tool of suite of tools there for you. The other important thing is that because it is a cloud-based license, it means it's very flexible. So it's really easy to take the units, use a bit of software and then put it back, meaning it's really easy to share between departments or even locations, giving you that the ability to push simulation out to more people. So Inspire Form is a complete stamping simulation product, but it does allow you to take what you need. So there is one mode which is just focused on feasibility. So we want to just quickly check the formability of a part, and that's all that's required. Or we can carry on and do a full tryout or incremental analysis, which allows you to visualize the process from blank to part. This means that you essentially only pay for what you need. The software itself is quite clean and easy to use, where you just follow a simple workflow from left to right. And again, you're going to see that shortly. So as I said, the first stage is feasibility. This is typically where you just import the part that you actually want to form. Perhaps this has come from a customer and you want to check the formability, where the software will predict any splits, wrinkles and loose metal. But you can also get a recommended blank shape where the software will then nest the blanks for optimal layout on a sheet or coil to maximize that material usage and reduce your waste. If you want to, you can then go a bit further, where you can use a tryout and incremental analysis, which basically follows a more traditional forming process, where you'll start with the blank and dies and are then able to analyze and visualize the various forming operations as they move through, being able to set up different operations like trimming and spring back, and to see how that's going to affect the overall part. You can see all of the deformation from start to finish and improve that process along the way to increase the overall quality. We won't be focusing on die design much today, but it's worth noting that you can rapidly create and explore die designs in the suite of products and then import that into Inspire Form when you're ready to run the simulation. So finally, before I hand off to Tim, so Tim, get ready. The software will help you quickly answer questions. So those questions might be more useful, perhaps when you're quoting a job. Can I actually form the part that you've sent me? What's the best material and how might this impact my costings? As I think about manufacture, how can I get the most out of my material, by choosing the right shape of blank and nesting them so I can make the best use of that? And how am I accounting for springback? And how can I amend my method to minimize any defects? So with that, I'll pass over to Tim, who will give you a live demonstration.
Thanks, Rob. I should have control in a minute. There we go. Hi everyone. So yeah, thanks for the intro, Rob. I'll be taking you through the Inspire Form software in a few minutes. Just to start off, obviously, you know, the main reason we use simulation and Inspire Form is to predict problems before manufacturing. Obviously, the last thing we want to do is go and produce a tool that isn't fit for purpose, that requires costly reworks or potentially a totally new tool. But also we can use simulation to sort of optimize our forming process, so we can use it potentially to reduce the time to market and reduce costs as well. One way of doing this may be, as Rob mentioned, if you are investigating, you've got potentials to use different materials. You can use 5, 6 different materials. Very quickly, you can use simulation to actually say, this is the best material to use. I'm just going to spend a minute on the user interface of Inspire Form, just because we think it's one of the cleanest interfaces out there, which lends itself to being very easy to use. We'd like to think any engineer could pick up Inspire Form generally within a day of using it. You're pretty competent on the software. So we have our two sort of modules. You can see at the moment I'm in the feasibility module. This is where we can predict early stage formability of our part. Also in this stage, as we mentioned, we can do blank layout analysis. So we can do nesting and blank layout, which basically just shows you the optimal material optimization of your part. Then we have the tryout stage. This is our sort of incremental solver, multi-stage operations. So here we can see a couple of the operations. I will be going through demos of these in a second, so don't worry about taking everything in. But this is our tryout stage. We do have a geometry tab. This allows you to make any geometry modifications if needed. Sometimes it may just save you, having to save a model out, going into your CAD tool, bringing it back in. If you can make a quick modification in this, or even send it to someone and then get it sent back to you. We do have some geometry modification features as well. Similar sort of thing with the sketch tab that allows you to create 2D sketches that can be turned into 3D models if you wish, but also can be used to modify existing 3D data. Views, the view tab, won't mention that. This is just really how you like to view things. You can see I've got a few things turned on here, my model browser and my property editor window, which is this left-hand panel. Edit, Microsoft shortcuts, undo, redo, copy and paste, everyone's comfortable there. And then the file tab, this is pretty standard throughout most softwares. Opening and saving, quick access to tutorials, screen capture allows you to record your screen, take screen grabs, and access the software sort of settings. In the left-hand corner here, we've got all our different views, so that allows you to snap to orthographic perspective, section cuts, different axes, all that sort of thing. And then the right-hand section, we've got our units that we're using. So that's about it in terms of the UI. We like to think it's pretty clean. Hopefully you'll see that as we sort of demo the software. So I'm going to jump into a demo. We're going to start in the sort of feasibility analysis. So this allows us to predict predict formability of the part early in the sort of product development cycle. Allows us to predict things like splits, wrinkles, loose metal. We call this sort of an inverse method, so we start with the 3D part and then we end up with a flat blank, so it's sort of inverse to how it would actually happen in reality. And obviously then we can also do our blank layout analysis. So first of all, let me just import a part. I'm just going to open a part. And we can import files from most different, most CAD softwares. So you can see here a few. We've got ASYS, we've got CATIA, Inventor, JT, Parasolid, Steps. So you name it, we probably don't have any issue importing it in. I'm going to open up this Parasolid file, which should come in a second. So now we can start the process. So if you import a 3D model into Inspire Form, the first step is to basically extract a mid surface that's presuming that the part has a uniform thickness. If it doesn't, you can always use a top or a bottom surface off the model. So that's the first step. We extract a surface. Here, obviously, the software will sort of predict what material thickness it is based on obviously the part. But if, for example, you have designed something to 3 mil and actually you want to do a 2.9 mil thickness, then you've got the ability to change that here. So you can define any thickness that you wish. So I'm just going to set that as 1 mil. The next step is to, if you need to, you can go into defeaturing our model. So there's not much to do here, but just to show you a couple of the tools in this defeaturing stage. For example, holes. I can fill that one in here, just defeature that hole. This cutout tool is quite nice. An example of this would be this area here, where I can just quickly sort of fill this area in almost. So you can see that happen there. And I'm just going to use my fillet tool just to remove these 2 fillets because I do want that to be a symmetry plane. So I'm just going to remove those. That's all nice, one nice straight edge. You can see we have a few other tools, but we're not going to be able to cover every single tool in the time frame we've got. But you can see those there. As Rob mentioned, sort of workflow left to right. So now we've done our first 2 steps, we can move on to material. Quite an important stage. Obviously at this stage you might be investigating different materials and hopefully you'll see the speed of analysis that allows you to do that quite quickly. But obviously it's important to sort of match the material you're using in simulation to the material you're going to use in reality. Otherwise you can't be sure that you're going to get the most accurate results. So we have a fairly comprehensive library of materials. These are a few steels, so a fair few of those, which you can see. And then we also have some aluminiums, so you can see those as well. If you look to the right hand side of this material database, you can hopefully see the mechanical properties of our parts. So we have our elastic properties, our plastic properties, and then our form and limit curve as well. If we go into the plastic properties, obviously important thing is our stress strain curve, which we can sort of see here, and that's made up of obviously these data points here. If you are using your own custom materials, you can create your own materials within the software, and that's pretty straightforward. Just click create material and then you can fill in your own properties and that sort of thing as well. So I'm not going to go too much into the material database, but obviously a very important step to making sure you get the correct results. So I'm just going to just close that down. Once you've done that step in terms of assigning a material, you can go into the orient stage. So basically this stage is picking a stamping direction. So the software will try to pick the most optimal stamping direction based on the part, and what it's trying to do basically is remove any negative draft angle. So we can see that this is the one the software has picked. I might not want this as my stamping direction, so I can align it to any surface, or I could align it to, for example, an axis. If we do have negative draft angle, the software will point that out. For example, if I just quickly change this to the y-axis, for example, we start to see this shading appear. You can see we've got the red and yellow shading on our surfaces. So that's showing you where this negative draft angle is, obviously based on this sort of stamping direction. So obviously that's not what we want to see. We can see yellow is between 0 and 10, and anything higher than 10 is sort of red. So if you ever see that, obviously that's just a bit of a warning, just to show that it might not be you might not have draft angle on your part one, or it might not be the best stamping direction. So I'm just going to set this to the z-axis, and I'm also going to set a symmetry plane, so I can do this with this tool. I'm just going to set this as my edge as my symmetry plane there. So I've done that. The final step, so you can see it's quite quick, is to basically constrain the part if we need to. I've got 3 tools here. We've got add any pins, we can add a blank holder, and we can also add a draw bead. So I'm going to start with a blank holder. I'm going to just define some surfaces that will act as my blank holder. So I'm just clicking on these surfaces, and they will be defined as my blank holder. So now if I click create blank holder, that will be created. At this stage, we can obviously modify our forces. So if I just click on and get to it, here we can modify our forces for our machines. So I'll set this to low, for example, and we can type in any forces here. Obviously, again, another important step. We don't want to be setting forces that our machines can't produce. So that's just another important step. But here, you can set this a low, medium, or high, or put in your custom settings. So I'll accept that, and then I'll just do one more. I'm going to create a couple of draw beads on this model. So let's just add some draw beads. I'm going to create one there, and I'm going to create one along this edge here. So I've constrained my part now. I've set it all up. I'm ready to run an analysis. That's hopefully showing you a fairly quick setup. If I click this tool here, this allows us to go into our analysis settings. You can see the operation that I'm doing a draw. We can also simulate a crash form, and we can choose our mesh size. That's the main thing here, is choosing the mesh size. I'm going to set this to medium, but you can set that to any mesh size you want. Have custom uniform or custom non-uniform mesh. A couple of things obviously important here is our friction coefficient. So obviously another thing that we don't want to set, too artificially low, because if it's set artificially low, you may get simulations that result that are passing, but in reality they wouldn't pass. So obviously that value is based on your sheet material, die material, lubrications that you're using. So obviously that's important. And we can also add spring back at this stage, so we can simulate for spring back in the feasibility analysis. So I'm going to click the run tool, and we'll sort of do this live just to sort of show you the speed of the simulation. I'm not going to sort of open up what I did earlier, because this will hopefully just give you a bit of an idea of how quick we can get results in this feasibility stage. So just to sort of explain what's happening, the first thing the software needs to do is transform or turn this model into the mesh. So it needs to create the mesh. So it turns these surfaces into that mesh. Then it's going into its different operations. So it's actually completed the drawing operation, and we're in the spring back operation now. Hopefully, looking at the screen bar in about 2 or 3 seconds. Well, it's now completed. So you can see that probably took like maybe less than 30 seconds, and we've got results, and that was using a medium mesh. So now we can load in our results. If I just click on this little green flag, and our results will be loaded. So just a couple of things to go through here before I look at the result sort of types. One, we can view the mesh. So that's our sort of mesh that's been created. So we can see that, and if you're not happy with it for whatever reason, obviously you can always change our mesh settings. Down here, we can sort of show the outline of the parts or not. We can snap to the formed part or the blank very quickly. So we can snap to the formed part and the blank. We can turn off the colours if we wish, and we can also show the thickened parts. So if I just zoom in on the side profile now, you'll see that it has now adapted that 1 mil sort of thickness of our part. So that's just a couple of things in terms of views. If we look at the animation now down here, I've set this to my animation settings. Again, won't go into too deep on those. I set this to a slower speed just so we can see this. But if I click the play button, we can see how our part is now formed. So we can see it's the inverse process. We're going from the 3D part to the flat blank. You can pause this, you can record it, you can snap to different steps yourself. So you can just snap through the steps. You can see we've got 12, and choose any one you wish. So that's in terms of the animations. Now we'll just quickly fly through some of the result types. So at the moment, the operation really is just a drawing operation. We can look at the spring back operation as well in a second. But these are our result types. So not going to go into too much detail on all the result types, because we could spend half an hour just looking at those. But these are the result types we've got. So you can see we've got thinning. If I want to find out what the value is at any certain point, I can put a call out on this area, and I can see the values. These callouts can be modified. You can show a number of different result types on these callouts, which you can sort of see here. So if I want the formability in that place as well, so we've got thinning, but it's actually safe. So other things that we can show in this stage, obviously stress, strain, press tonnage, and displacement. But obviously one of the main things is our formability limit diagram. So if I just make this a little bit bigger so you can sort of see it, and let's just move that a little bit out there. So obviously this is our formability limit diagram. So obviously, you know, what we're trying to get is as much green as possible. And if we look on the right hand side, we can see red is obviously failures, yellow is marginal, green is obviously safe, and green causing loose metal. So there's not much red here, but there is a little bit of red. I don't know where that part is. I can try and zoom in and have a little look and see where it is. That's pink. I thought that was red. But I might not know where this is on the model, so I want to know where this failure point is. So if I click on it with my callouts activated, it'll just pull up. It'll just put a call out on that exact point, so I know now that's the failure point. And that's where we might be seeing a split or a tear. So obviously just draws your attention to that point. So that's quite nice being able to just put call outs in any of these areas. But that's our forming limit diagram. So that's it for the results. Obviously, feel free if you've got questions, put them in the chat box, and we're happy to answer those after the session. Once you've done your analysis, one thing you might want to do is generate a report. So you can do that here, basically just choosing your model setup and the result types that you want to show. So you can see all these here. That will look something like this. Again, you're still seeing my screen. So you can see here, this is our report. The template and stuff, that's all fully customizable. So you can also put your own logos and things on there. But this will create a PowerPoint that obviously you can send to whoever you want. If you've got call outs and stuff, they will also appear on the report as well. So that's just generating a report. Then going into blank layout. So obviously once we've done our analysis, we will have a blank. So now we can do the blank layout analysis. So just click in the play button here just to show you how this would work. So this is my blank just over in a rectangle shape, but we can see it. We can fit this to any shape. We can fit it to parallelograms, sweeps, chevrons, trapezoids. And we can set up, obviously, all this sort of stuff can be modified in the settings. This is just set to US dollars, but we can set up whatever currency you're using, and obviously you can add an addendum there. Similar sort of thing with the nesting analysis. If I hit the run button there, similar sort of thing here. We can set our patterns, type, whether we use a coil or a sheet, and that sort of thing. So let me just open a quick file just to show you what that will look like. Just say don't save. So if I click this one should hold some results. I don't think I mirrored this one or set any symmetry plane, but this is the sort of results you'll get. So this is obviously the blank, but it's on currently showing it in a parallelogram, and you can see the material utilization down here. So 80.5% material utilization, rectangle, not much different to be fair. And if I just double click them, it'll snap to the rectangle, 80.1. So you could choose between either of those without too much issue. Obviously, I probably wouldn't want to choose the sweep shape. If I double click that one, material utilization is not the best. So any of this information can be exported out. You can save the DXFs, IGES files, all that stuff can be accessed. If I just open the nesting just to show you similar sort of thing with the nesting, you can see here again all the patterns that I've got down here. Let's just jump to another one, and we can then start to look at our material utilization through the different patterns that we've got set up there as well. So we've got 90%. And as mentioned, these are all there in the files for DXFs, IGES files that can potentially be used in other software if you need them as well. So that's blank layout. I'm going to jump now into the tryout stage. So this is going to be our sort of multi-stage solvers. Let me just create a new file, and I'm going to import another file now. Let's open up this one. So In the tryout stage, it's obviously a little bit different. We start with a flat blank and generally our die tools, and then we work obviously towards the form pass. So just to show you what I've got in this design, I've got my flat blank, which is this. I've got my surface that is going to be representing my top die, and then I've actually got some trim curves as well, which we can see here. So I'm going to do a number of operations here, which will hopefully give you an idea of how this works and how this is set up. So again, let me just turn on all these things. Working from the left to the right, so first thing to do is define our blank. So this is my blank. If you are doing tailor welded, we can do tailor welded blanks as well. I'm going to click assign, and here you can specify the thickness and your material. So same material database that I just showed you earlier, so I won't go into that. And I'm just going to leave it as a default. So I'm going to click apply. You can set your rolling direction. That's if it has come off the coil, you can set that as well. Not going to set any symmetry, don't need any in this model, or any constraints here. I can do that here. So I'm going to basically start creating my operations. So just to show you the operations that we can add, these are the different ones that we can sort of run. And also you can create your own custom operations as well. So you can create your set, your tools and stuff. So I'm going to add 4 operations in this example. I'm going to add a single action. I'm then going to do a trimming operation, then a flanging operation, and then I'll analyze for spring back. So those are my 4 operations that I'm going to run. These can all be reordered. You can drag them, you can order them in whatever you want. Obviously, this is the order that they will run in, so obviously you want to get that right. But these can all be reordered. You can rename them, you can delete them, so you can customize your operations as you see fit. If we go into the single action, that's where we're going to start. You can see that we've got our tools, our default tools that have been assigned: top die, bottom binder. But if you aren't using those, if you're using pads, draw beads, any of these tools can be removed and added, so you can customize each operation as you see fit to match your machines. I'm going to leave that as a default. Another nice little tool at this stage is the ability to auto configure our tools. So I've just got a top die at the moment. If I click this auto configure and I click build tools, I'm going to click that, and the software will hopefully end up with a top die, a bottom die, and a bottom binder, because those are my 3 sets of tools that I chose. So you can see here now, color scheme, we've got the blue top die, we've got our blank, and we've got this sort of orange bottom die, and this is our binder, sort of slightly different orange color. So those are our tools. You can then go in and modify them. So again, if I click on my top die, we can modify our friction values, we can modify the distance to closed, and the same with our bottom die, and obviously our forces for our binder as well, obviously to match our machines. So these can all be customized once they've been created. You can also sort of preview the tool motion, so we can see preview that motion just to give you an idea and making sure that it is going to close. But now let's move on to the trimming stage. So if I go into this one now, I'm just going to hide the blank, and here we can specify a trim, pierce, or a lance. I'm going to just assign a trim to this curve here, and click assign, and assign then a pierce to this, and haven't got any lancing, or edges to define as lancing, so we don't need to do any of that. So that's it for the trimming stage, pretty quick. Then we can move on to the flanging stage. I haven't got any geometry for my flanging stage, so I'm going to import something in. So I just need to go to File, Import, and let's just import this tool. So in the flanging stage, again, similar to the single action, feel free to customize and modify to set up your own tools. I'm going to start with the bottom die and define this as my bottom die, but rather than assigning it, I'm going to offset it. So then I'm going to click create, and that will offset that as my bottom die. Again, we can customize the offset direction and distance, but I'm going to accept the defaults and our friction values again. Then going to go into top die and assign, this is the top die, so this time I'm assigning it rather than offsetting it. Again, similar sort of things, distances and friction values, obviously making sure we get those correct is important. And then I'm going to click apply. And then for my top pad, rather than the part, I'm going to specify some surfaces. So I'm just going to just click on a couple of surfaces to define as my top pad. And I'm actually going to partition these. Again, forces, friction values, apply those. So finally, I can now apply, just set my spring back up on here. I'm just going to just use the auto configure, and that should be good to go for my spring back analysis. So this is just a 4-stage operation. You know, you can have one stage, you can have any stages you want. Feel free to customize this however you see fit. When you're happy with it, same as the feasibility analysis, we can then go and run our model. Again, the main thing here is sort of mesh size, so you can customize your mesh size to suit. You've got your animation frames as well. So so this is the setup. I'm not going to run this one. I'm just going to show you some results because this will take a little bit longer than the feasibility analysis, just because we've got a number of operations and we haven't really got time to be sort of sitting here and watching something load for 5 minutes. So I'm going to just open one I did earlier. So this is this one with some results. So let me just load in the results. Let's just close that. So what I'm going to show you here is I'll just play the animation for you. This will simulate all the operations. So this will go through the single action, then into the trimming, then into the flanging operation, and then do spring back analysis. So it'll run through them all. Might be a bit quick, but you'll get an idea. I'll just play this a couple of times. So I'm going to hit the play button now. So that's the first one, spring back analysis. Then it jumps into the trimming. Then we're doing the flanging. And then finally we're doing spring back analysis. It's a little bit quick, but obviously if you were using the software yourself, you can play these individually. You can go through them at whatever speed you want. So these are all the different operations. And again, similar to the feasibility analysis, we've got our different result types as we go through. So again, not going to spend loads of time on the result types here, but just to show you the different result types, you're going to get a few more in the tryout analysis. So we can see our thinning, thickness, delta this time, and a few others that we wouldn't have got in the first time. So we've got contact forces, skid marks, and other things that we wouldn't see in the feasibility analysis. If I look at my performability limit diagram again, I can see on my part I do have some failure, so I'm obviously going to get some tear along this area here. That's obviously, of course, a concern. And then if we look at spring back analysis and I look at displacement, we can start to analyze our spring back displacement, and again we can put call outs in any of these areas. We can visualize this so we can start to visualize our sort of spring back. We can put traces on areas as well, so that's just another thing to note. One thing we can do now we've got our results is we could redesign. We could use these tools if we wanted to redesign. What this one does is it will adjust the dies when you hopefully read that, but it adjusts the dies to counter the known spring back. So we'll just slightly adjust the dies to obviously adjust for that spring back that's been created. So we'll just readjust them ever so slightly. This one will basically predict the best blank shape. So it'll predict the best blank shape of your parts, and hopefully to allow you to optimize your material as well. Again, same thing here. We can create reports. So that's just exactly the same sort of thing with the feasibility stage, you choose what you wish in the reports, and you can generate a nice PowerPoint report to send off to whoever you need to. One thing that Rob mentioned was the ability to do die face design. If I just open up, I'm not going to do a big demo on this, but if I just quickly open up something, that's not the one I wanted. If you had your part and not the die, let's just open up the first one, which is that one. We can open up your parts, but as Rob mentioned, you do get access to a couple of other tools. You can right click and basically open in Studio, which is this software. And basically in here, you can, this is the same model, but this is just a very simple one. But we can do die design in here. So basically the workflow is basically left to right again. You assign your parts, and then the symmetry planes, if there was. So that's a symmetry plane. Defeature it if you needed to. Create a binder or assign a binder if you've got one. So I'll create a flat blinder. Then we could create some addendum, and here I'm just going to just create straight lines, and then once you've done that, you can then go into die and create your sort of tool. So that's just a very basic demo, but we do have die face design as well, and that can then be exported back into Inspire Form as well. So that's just a quick example of die face design. That's pretty much the demo over. It's a lot to go through, so if you have got questions, I will try and answer them at the end. But I'm going to pass you back to Rob now, who will then have a little chat with the customer. It's always great to hear what customers think of the software they're actually using. So
thanks, Tim. Thanks, Tim. Yeah, a rapid demo, but it was all live, so well done. You got through it all. Running out of time, so we are going to hear this interview. It was recorded literally 2 days ago, so it was very recent, and it was done specifically for this webinar. So we'll listen to that. It runs for about 15 minutes. Get your questions in as we're going through that interview. And I think, Corinne, there will be a couple of minutes at the end just for some questions. So if you want to start that interview, that would be great. So first of all, Jay, thanks very much for giving us the opportunity to have a short chat with you about your business and experience using simulation. I know it will be really valuable for everyone listening to hear from someone that has been through the process of implementing simulation, and also to understand what the potential benefits are. So thanks very much for making yourself available. Before we get into the detail, just to kick things off, can you just briefly introduce yourself, Jay, and tell us a little bit about your company, what services you offer, and what sectors you operate in?
Sure. My name is Jay. I am the founder of a company called BiggerBoat Solutions Limited, and I do primarily metal forming and most aspects of die engineering. 95% of my work is in the automotive sector, but I do forming simulation for appliances and buses and pretty much electronics, almost anything. Metal forming is sort of metal forming. It doesn't really matter what sector you're in. It's all the same thing. I was saying I started in 2010, right after the automotive crash. I got tired of hunting around for a job from different tool shops. So I said, to hell with it. I'm going to start my own shop. And that's what I did. And I've been going on since then.
Right. Well, it's brave to start your business just after that crash, but you're still here. So you must be doing something right there. Thanks for giving us a bit of an introduction in terms of what you do. Now I know you've been using simulation for a while now. But if you can sort of cast your mind back, what were some of the challenges that you might have faced either within the business when you started up or in previous jobs prior to actually using simulation on your projects?
The tool shop that I worked for most of my career initially was very hesitant to get into simulation because they didn't trust it. How could a computer predict what metal's going to do when you form it? There's too many variables. It's too complicated. It was sort of a black magic art, tool making. And then little by little, I pushed the owners of the company to try it. And then once that happened, they never looked back. It cut down cycle times. It improved accuracy. It made the whole process of designing and troubleshooting and buying off the tools substantially easier.
Yeah, okay. So it's just a case of, I guess, proving the solution to the management team in terms of, actually that it is accurate and it will do what it says on the tin. And then you sort of saying after you manage to get over that hurdle, it made sense. We hear that a lot in terms of what we're doing, and there will be many people listening perhaps to the call that haven't invested in simulation yet. It's useful to hear that your method was sort of to validate the results, which got them to invest in the simulation. How did you go about doing that? Did you sort of look to simulate something that you'd already formed and therefore you knew what the defects were? How did you sort of build confidence in the accuracy of the solution with the management team?
So it started with simulating projects that we had finished. We knew what the problems were. We knew what the results were. We knew how much spring back we needed. We knew what we had to do. So I would run those and show them, look, the simulation is predicting exactly what we ended up with for these jobs. That was the first step. And the second step was I would simulate things, and they wouldn't really want to use the results straight away. So we would still simulate it, have the results in our back pocket, and then manually sort the tool out and get it to work. And then we would compare the simulation results to what we did in real life, and they correlated. Once that phase was done, we simulate and go by those results all the time. And today, that's critical. You can't not simulate today. You have to. The parts are too complicated. Timelines are too compressed. You need to have simulation to get into the tool with as few problems as possible when you do your first hits.
Yeah, that's really interesting. I do have a question later on just to elaborate on how you see simulation in the marketplace. So I'll come back to that one. There are obviously a number of forming simulation tools out there. Some people on the call today or listening to this perhaps already have simulation in place, or some people might be looking into simulation and have lots of options on the table. So I'm just wondering if you could talk a little bit about why you decided to actually partner with Altair for forming simulation, and whether there was anything, I guess, specific about Altair and its products that sort of gave you the confidence that it was the right solution for your business.
So during the course of my career, I've pretty much used all of the forming solutions that exist out there today. I'm not going to ramble them off and give, free airtime to the competitors, but I've used them all. And when I was starting my company, I tried them all to see what would best fit for me in terms of how I worked and my workflow and how I did things. And there are good and bad aspects to all simulation packages. If they're used correctly, yes, they're all going to work. But in the end, Altair's solutions were the best combination of accuracy, functionality, and cost for doing metal forming. And also because they have such a large suite of products, I used their products in ways that no one ever expected them to be used because I could.
Yeah, I mean that makes sense. And I guess I guess just to make that clear, obviously what you're talking about there is the fact that when you buy into Altair, you might have a particular use case for simulation, which in this case might be forming simulation. But what you're saying is there's a whole plethora of other tools in the Altair product suite that you can leverage through the units-based system, which actually means that you've got a vast sort of set of products which you can utilize, maybe not instantly, but as you sort of progress with Altair, you can use more and more of their technology, right?
Yeah, that's exactly right. And the way it would work is I would run across a problem I needed to solve, and I wasn't quite sure how to do it. So I've got a very close relationship with Altair Canada. So I would call them and say, Greg Delbridge is the one I usually bugged about this. I would call him and say, I have this problem to solve. Is there something in Altair suite of products that will allow me to solve this problem? And an hour later, he's like, you could do this, 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 and this. I'll write you a quick script, and here's how your problem is solved. And, we tweaked it as we go, but they're very good at solving problems, I'd say. Their support is good at solving problems and thinking, I don't like the term outside the box, but they're thinking creatively to use other things from their product suite to solve metal forming issues that you don't think you're going to come up against, but you do throughout the time of using it.
Now, you've alluded it to a bit earlier, and I just wanted to sort of come back to it, because one of the things that you spoke about, Jay, was that simulation is an absolute necessity. And you'd mentioned the complexity of the parts, and I think you mentioned the cycle times as well. And interestingly, one of the questions that I wanted to ask you was, do you feel that simulation has differentiated your business in the marketplace, perhaps in terms of organizations that might not be so advanced or might not even use simulation? Or would you actually say that, no, it's not differentiated my business because it is just a necessity? And if you want to get those large orders or want to work with larger OEMs, you just absolutely must be using simulation anyway.
Yeah, simulation has not differentiated me because you must be using it. Everyone across the board. It's required for 99.9% of all parts need simulation, as even if they're a dead simple L bend for some reason. And that's just the way it is. So everyone needs to be using simulation. What differentiated me was the things I could do with Altair products that people with other solutions couldn't. I can give you an example. I can give you an example of one big one. So in many cases, if you've got a forming, say a generic part, you're forming it and you're in the press bluing it in. You've got areas where there's the tool steel is too close together because you've got compression, or you're getting a lot of thinning, so you've got a larger gap and you're not hitting the part true. I worked with Greg Delbridge from Altair Canada, and we worked out a way to take the thinning results of the simulation and then map it back onto surfacing, so I can then modify surfacing to take the thinning distribution into account, cut that into the tool so you hit more true than you would with just straight away cutting the nominal or whatever sprung back compensated surfaces. I'm now taking thinning compensation into consideration, not just like spring back.
Yeah, that makes sense. So it's what you're saying to summarize is that everyone should be using simulation, but actually you've been able to, I guess, use different tools and techniques to almost allow you to deal with a greater level of complexity, and I guess bring more accuracy in terms of what you're doing in terms of simulation. So that's really interesting. And I think still some businesses aren't using this type of simulation. So I wonder why that might be the case. Is it more that because you're working predominantly in the automotive sector and that they dictate that simulation must be done? Or is it actually you're saying, across sector, everyone should be using it?
Automotive is dictating it, so it has to be done. It wasn't dictated so much across other sectors, but it is being used now because they see the benefits of doing it. The tools are better, the product is better. There's no doubt about it anymore. It's not like it's a new technology you have to prove out. It's well developed, well understood. and everyone knows it just works.
Yeah, I mean, yeah, it makes perfect sense. There is one more question. I know we're running out of time, but there was one more question. I mean, clearly you've been using simulation for a while, so you know you've got the technology knowledge, and you clearly understand the process of forming. So you've got I guess process expertise in addition to simulation expertise. Many people might want to start using simulation more. Companies might want to be rolling out simulation to more members of the team, where those people might be process experts in terms of forming, but they might not be too familiar with actually using simulation tools. So do you think people with process knowledge, but not necessarily experts in simulation, would be able to utilize a tool like Inspire Form, with the right training?
I think it's more important to have process experience than actual computer simulation experience. If you understand how the tool works, how to get metal to flow, why things do what they do, learning the mechanics of running simulation software is the easy part. Understanding tooling, I think, is much, much more important. Inspire Form is that easy to use.
That's quite interesting, because we speak to people in our business that have an awful lot of process knowledge, and actually feel like, compared to people with a high level of technical proficiency in terms of software, that those people will be at a disadvantage because they've never really used it before. But from what you're saying, those people will probably be able to be more effective with simulation technology because of that process expertise, rather than vice versa. So I think that's
exactly right.
Yeah, quite an interesting point, and I'm not sure I've heard it positioned in that way, but it does make a lot of sense. So look, I think that's all we've got time for today, Jay. Thanks very much for answering the questions today and telling the people a little bit about how you've been using it. I think it would have been really useful for those that have been listening. I'm sure if anyone does have perhaps additional questions for you, Jay, I'm sure they can probably contact you through LinkedIn, perhaps, or your website, maybe.
Yep,
for
that's fine.
Brilliant. So we'll perhaps make those details available. But yeah, once again, thank you very much for your time, and have a great day.
You too. My pleasure. Have a good day.
Thanks, Jay.